We have discussed the Carnot cycle and reversibility in the previous video. So it was Carnot cycle we discussed in the last video. So a cyclic heat engine operating on the Carnot cycle can be termed as a Carnot heat engine. So if you got a cycle operating in the completely on the Carnot cycle, then you can call this engine as a Carnot heat engine. So because all the processes in Carnot cycle is reversible, the Carnot heat engine will be completely reversible. Let's see how a Carnot heat engine will work. As discussed in the previous few videos, you will have a source at a temperature T1, from where you get a heat of let's say Q1, and there will be a heat exchanger here to accept or to take this heat, and from the heat exchanger you can see the fluid, the working fluid, will be transferred to the turbine, where you have a work output from the turbine. So the fluid flows through the turbine. In most cases it will be if we assume a power cycle or a power production plant, then the working fluid usually is if it's operating on steam, then the working fluid will be water and steam. So you have your steam coming through the heat exchanger here and passing through the turbine blades, generating turbine work, and then at the exit of the turbine you will have another heat exchanger which will reject a heat, say a Q2 is a heat exchanger, and this is a heat exchanger. So you will have a heat exchanger here which is rejecting heat Q2 to a sink or a temperature source which is at T2. Now the rejected work heat rejected working fluid will be pumped back. So you will have a pump here like this, and the working fluid will be pumped back into the top high temperature heat exchanger, and here you will need to provide a pump work. So net work output from the reversible heat engine cycle will be as you can see, the net work will be turbine work output minus pump work. So that will be your net work output, and your net heat input will be Q1 minus Q2. And because all the processes are reversible, you can see the flow is shown here in this direction. Because all these processes are reversible, we can reverse all the processes, and you can create a reversed Carnot or a reversed heat engine. A reversed heat engine is simply reversing the processes of a Carnot heat engine. So this is how a Carnot heat engine works, which is taking heat from a high temperature reservoir, operating through the turbine, operating the working fluid through the turbine, and rejecting heat at a low temperature reservoir, and then pumping back the working fluid to the high temperature heat exchanger, and completing the cycle. So if you remember the last diagram that I have shown here, you have processes like this, like 1 to 2 your heat input, and 2 to 3 your work output, and 3 to 4 your heat rejection, and 4 to 1 your pump work. So that's exactly what's happening here. You have your 1 to 2 where heat rejection, so let's call this 1 and 2. That's 2 here, and you have your 0.3 here, and your 4 here. So 4 to 1 is the pump work that is shown here. And you can also, if this is a PV diagram, you can also show the same Carnot heat engine on TS diagram. We will discuss, as again we will discuss the TS diagram later on. It will be like this: 2, 3, 4. As mentioned in the previous video, these two, 1, 2 and 3, 4 are reversible isotherms. These are happening at constant temperature, and 2, 3 and 4, 1 are reversible adiabatics, where there is no heat transfer, only work transfer. And this is your TS diagram. It's exactly showing the same processes here: Q1, Q2, WT and WP. Now what if we reverse this heat engine? Let's see what happens if we reverse the Carnot engine. So all the processes will reverse. So what you have is your low temperature heat reservoir. You have a heat taken from this, lower amount of heat taken from this to the heat exchanger, and flow will be reversed as well. So it will flow into the turbine here, and from the turbine it will go back to the high temperature heat exchanger, where you will reject the heat to a high temperature reservoir. And the flow is exactly reverse to what happened in the cycle, in the Carnot cycle. So it is a reversed heat engine. So here you complete the cycle. So you take work, turbine work here, and you reject the pump work here. So the flow is reversed, and so is the heat transfer and work transfer. Now here again, here the turbine work will be higher, and net work will be WT minus WP. The only difference here is this is creating a low temperature, and it is decreasing or reducing the temperature of this sink or the temperature source. So a reversed heat engine can be termed as a heat pump or a refrigerator. I'm sure you are familiar with this term, the refrigerator, but you may not be familiar with a heat pump. But a heat pump is simply a device which is taking heat from a low temperature source and rejecting heat to a high temperature source. An air conditioner, a cooler or an air conditioner or a refrigerator are all examples of a heat pump or something that could transfer heat from a low temperature source to a high temperature source. So again, this is a reversible process, a reversed heat engine. This is the ideal case. This is not practically possible, but it is possible to produce a refrigerator and heat pump with losses, which means that is not reversible. Obviously there will be heat losses and friction losses, etc. But the concept of heat pump and refrigerator is originated from or can be discussed described from the concept of the Carnot heat engine. So Carnot heat engine and a reversed heat engine or heat pump or refrigerator. We will discuss the refrigerator and heat pump and the coefficient of performance of refrigerator and heat pump, etc. in the next videos. Thank you.